Hey guys, so this is going to be an intro to trig kind of refresher. So this will help you study for your test. This will help you if you haven't been here. This will help for our new students. This is going to be following the worksheet that we did in class. If you don't have the worksheet, that's okay. You'll be able to just copy down the problems into your notebook. Okay, so if we have a right triangle and we know one of the acute angle measures, and remember acute is less than 90 degrees, and one of the side lengths, so that's not including, well that does include the hypotenuse, remember, because this is a right triangle, we can look up the pattern of the ratio of the side lengths to solve for either the missing side length. So that's a lot of words. But if you look at this triangle that I have here, I have a right triangle, which is denoted by this beautiful right angle. I know my acute angle measurement, one of them, is 18 degrees, and I have one side length, but I need to find this right here. This is what I'm looking for, this big question mark. Okay, so we can actually look up those ratio of side lengths in order to solve for the missing side. So this table right here, this is a table that we would have used lots of years ago if we didn't have a calculator with those with these three buttons here: sine, cosine, and tangent. So basically what I'm saying is, if you don't want to have to use this chart, I need for you to get a calculator with those three basic trig functions. Okay, we're going to talk about what they are and what they mean. If you end up needing the chart, I can get one for you and I can show you how to use it. Otherwise, we're not really going to do too much with it. But what this chart is giving us is the ratio of side lengths, which we're going to talk about now. So before we get going with those ratios, we're going to start really simply with just labeling right triangles. So on each of these triangles below, we're going to label the hypotenuse as H, the opposite leg of angle X as O, and the leg adjacent to angle X as A. So looking at this first triangle here, angle X is the one that's been circled, and the side length that is the hypotenuse is always opposite of the right angle, so it's labeled as H. The side length that is opposite of angle X, again, if this is angle X, it's going to be the side length that doesn't touch that angle. That's going to be ZY over here, and that's our opposite side. And then the leg adjacent is always going to be that last one. So what I want for you to do is go ahead and pause the video and try labeling these three triangles. When you unpause, I'll go through them. So if this is my angle X and this is my right angle, I can label hypotenuse, opposite, and adjacent. Remember, hypotenuse is always opposite of the right angle, so this will be my hypotenuse. If this is angle X, the opposite side, all the way on the other side, is my opposite, and the one right next to it is adjacent. Remember, adjacent is just a fancy word for next to. Come to the third triangle, we have our angle X. This will be our hypotenuse, this is our opposite, and this is our adjacent. If this is my angle X and this is my right angle, this is my hypotenuse, my opposite side, and my adjacent. If you feel comfortable with that, feel free to move on. Okay, so on each of the triangles below, you're going to have to write the ratio based on the opposite hypotenuse and adjacent legs for that angle X. So if you look at the example, this first one here, if this is my angle X, my opposite side is that 12, and my adjacent side is 5, my hypotenuse is 13. What I wanted was the ratio of the opposite leg to the hypotenuse. So I labeled my opposite leg as 12, that's going to go in the numerator, and my hypotenuse was 13, that goes in the denominator. Go ahead and pause the video now and try it for the next three triangles. So I've already labeled all of the sides for these three triangles. Now we're just going to fill in these ratios here. So the second one asks for the ratio of the opposite leg and the hypotenuse. The opposite is 7, so that'll go in my numerator, and the hypotenuse is 25, that goes in my denominator. For the next one, the adjacent leg is 3, that goes in the numerator, and the hypotenuse is 5. And then finally, the opposite leg is labeled as 8, and the adjacent leg is 15. So what we have are those three ratios here. So what I would like for you guys to do next is go ahead and pause the video, and using your calculator, find the decimal value for each of the ratios above to 4 places if possible. So for example, on this first one that was done for you, we had that ratio of the opposite leg of the hypotenuse, 12 over 13. I want you to now go ahead and put 12 divided by 13 on your calculator, and you should get that 0.9231. After you get that, I want you to try the same thing for 7 over 25, 3 over 5, and 8 over 15. Go ahead and pause the video now. So after putting each of those ratios in, these are the decimal places that you should have gotten. If you feel comfortable with that, go ahead and move on now. Okay, so those ratios that we just did, the opposite leg over hypotenuse, the adjacent leg over hypotenuse, and the opposite leg over the adjacent leg actually have names, and this is where our trigonometry comes into place. The opposite leg over hypotenuse is our sine. Our adjacent leg over hypotenuse is cosine, and opposite leg over adjacent leg is tangent. These are going to have to be something that you remember, and the way that I like to remember that is this SOHCAHTOA. But instead of writing it how we see here, what I'm going to do instead is write sine of opposite over hypotenuse, cosine of adjacent over hypotenuse, and tangent over opposite over adjacent. So we have SOHCAHTOA. So one way you might remember this is this mnemonic device, if these work well for you, is some old horse, so sine opposite over hypotenuse, some old horse caught another horse, ka, taking oats away, toa. I know that works for some of the kiddos in our class. Sorry, be sure you write these down because it's going to be very important. Okay, so we're actually going to practice using our calculator now. So this asks us to use our calculator's trig buttons to find the value. So when it says find the value of sine 67 degrees for 4 decimal places, we're going to go ahead and pull out our calculators. And you'll notice on mine here, I have this little thing up in the top where it says DEG. That's degrees. If yours does not say degrees, you need to go into your mode and change it to degrees. So you'll notice I have the options for degrees, radians, or gradients. We're going to be working with degrees, so make sure it's selected on degrees and then press enter. Oh, sorry, press quit. And so now what we're going to do is we're going to put in that sine 67. So first we're going to hit our sine button and then put in 67 and close those parentheses. Once you have that, press enter and we get this decimal. We're going to round to 4 decimal places. 0.9205. Go ahead and write that down, 0.9205. Go ahead and try that on your own. If you go back to your calculator for the next two, it's asking for cosine of 67 degrees and tangent of 67 degrees. On your calculator, there's a button for cosine, here's mine here, and a button for tangent. You're going to do it the same way we just did for sine. Go ahead and pause the video and try that now. Alright, if you plug those in, you should have had these two answers, 0.3907 and 2.3559. If you feel confident, go ahead and move on. Alright, so what we're going to be doing now is we're going to go back to what we started with, where we're going to label our triangles and we're going to write out the ratios, but then we're also going to solve all the way. So I'm going to do the first one with you, and then I'm going to have you do the last two on your own. So for this first one here, it says find sine K. So what we're going to do is we're going to go ahead and circle our angle K. That's our reference angle. And now I'm going to label my side lengths based on that. My hypotenuse is always opposite of my right angle. If this is my angle K, the opposite side is going to be that 12 centimeters, and then my adjacent is the one right next to it. If we go back to that SOHCAHTOA, which we're going to use and rewrite all the time, so we have SOHCAHTOA. This is asking for sine of angle K, so we're going to use this ratio here, opposite over hypotenuse. My opposite side length is 12 over my hypotenuse, which is 13. If I put 12 divided by 13 in my, 12 sine, if I put 12 divided by 13 in my calculator, I'm going to get approximately 0.92. Go ahead and try that for the next two on your own. Pause the video now. Alright, when you plug the next one in the calculator, first you need to label all your sides, figure out what you need to do. So I have my SOHCAHTOA written up here. Cosine is my adjacent over my hypotenuse side, 5 over 13, which is approximately 0.39. In the next one, we're looking for the tangent of angle K. Again, label my side lengths. Tangent is opposite over adjacent with that SOHCAHTOA. Tangent opposite over adjacent, which will be 12 over 5. I'm sorry, yep, 12 over 5, which is approximately 2.4. If you feel confident, move on to the next. So here's our last few questions before we finish with this video. It says, what do you notice about the calculator values you found at the top of this page? Again, this was a worksheet. And the trig ratio values you got by using the side links above. So we go back to this previous slide here. Oops. We had sine of k was 0.92. When we put sine of 67 degrees in our calculator, we got 0.9205. That's pretty close. If we look back at what we did for cosine and tangent, you'll notice that again, those numbers are pretty dang close. Tangent, when we had our ratio, we had 2.4. If I were to round this to the nearest tenth, I'd get 2.4. So going to this last question that we have here, what you notice about the calculator values you found at the top and the trig values, we notice that they're pretty much the same. They're very, very close. So if they're very, very close, what is that going to mean about the measure of angle K on this triangle? Well, originally we are finding the value of sine 67 degrees, cosine 67 degrees, and tangent 67 degrees. I would say that's a pretty good guess then that this sine K, if it's also 0.92, this K measures 67 degrees, or about. So that would tell us that the measure of angle K is about 67 degrees. This is going to be very important for when we move forward in trig. But if you're feeling good with that, go ahead and you'll be able to move on to the next video.